So my chapter is chapter 14, Digital Enterprise Architecture for Global Organizations by Yoshimasa Masuda. So before we begin, let's start with a short introduction on enterprise architecture. So enterprise architecture visualizes the current corporate IT environment and a business landscape to promote a desirable IT future. So EA is required as an essential element of corporate IT planning, and it's not a simple support activity, as mentioned by the author. And it also offers many benefits to companies, such as coordination between business and IT, improvement in organizational communication, information provision, and reduction in the complexity of IT. But the goal of this chapter is to show that a strategic architecture framework aligned with digital IT strategies should be the framework of a digital enterprise architecture. So, our flow of discussion will first be on the direction of digital IT. So, it explains the direction, such as in cloud, mobile IT, and specific application layers on cloud, like the big data and the Internet of Things. Next, we will move on to discussing five of the EA frameworks selected. So there are actually a lot of EA frameworks, but only five were selected based on two criteria, which we will discuss also later. Uh, and then we will move on to the problems found in enterprise architecture, as well as the proposed solutions by the author. And then finally, we will move on to the conclusion. So let's start with chapter one, the first part of the presentation, which is the directions of cloud, mobile IT, and digital IT. So the author noted there are three main directions, uh, which are cloud architecture, service-oriented architecture, and microservices. And lastly, specific application layers on cloud, which include big data and the Internet of Things. So let's first discuss cloud architecture. So cloud architecture is a cloud uh, compute is a defined by NIST as having three service models, which are SaaS, PaaS, uh, IaaS. So if you remember from our last class in cloud, for those who were there. And also, the cloud architecture was also pioneered by, uh, the Open Group also pioneered an architecture which is the Open Platform 3.0 standard. So it includes basic architecture models, as well as it is also focused on trends in cutting edge tech that creates new business models. So let's discuss the SaaS, PaaS, and IaaS and differentiate them. So here's a quick visualization. So SaaS, PaaS, and IaaS are the three service models, and PaaS is an IaaS platform that includes both system software and an integrated development environment. SaaS, on the other hand, which is software as a service, is a software application that is developed, implemented, and operated on a PaaS foundation. So, by the way, PaaS is platform as a service. And also, the SaaS interface is accessed through the client and API interface. So, the IaaS accommodates PaaS and SaaS by offering infrastructure resources such as computing, network storage, memory through specific centers. So another part of the direction is service-oriented architecture and microservices. So they vary greatly from viewpoint of service characteristics. So SOA is a cooperative design method in which multiple services provide different functions and has been used in large-scale monolithic applications. And the SOA architecture also has four basic forms. So these are from a business service, enterprise service, application service, and uh, the infrastructure service. And microservices, on the other hand, uh, is defined as an approach for distributed systems that promote the use of finely grained services with their own life cycles while integrating newly emerging technologies. So microservices is an approach for also for dispersed systems defined from two basic forms uh, and from functional services through PI layer and through infrastructure services. And it also enables early adoption of new technologies such as mobile IT and cloud computing. So here is a quick visualization of how they work hand in hand to support the business. So from business service on the left side, so you can see how business services flow into the messaging middleware towards enterprise services, application services, and so forth. So, okay. And then lastly, from the direction perspective, so the first specific application layer would be big data. So big data applications leverage web services that make uh, the results of their analysis available to other applications. So the term big data refers to data that is so large that it is difficult to process using currently available IT systems. So it comes from two sources. Uh, First is corporate data. So in C- it's usually presented in SQL databases, uh, data in cloud-based SQL or NoSQL databases, as well as, and the second source is the IoT data, which are usually provided by social networks, uh, by sensors in the Internet of Things, and uh, a lot of uh, those miscellaneous sources. And also, the purpose of using big data is so that we can apply uh, the application in visualization functionality uh, for effective user presentation of analytical results. So the next application layer is the Internet of Things layer. So it's a collection of uniquely identifiable objects embedded in or accessible by internet hosts. So IoT also revolutionizes digital strategies with innovative business operating models. So some examples are the sensor, control, or a combination of both. So with sensor, there's temperature sensors, uh, controlling a valve in a heat system, and combining them, you get thermostat. And also, lastly, is the object identifier. So an example would be like an RFID tag or a barcode. So those were the specific directions identified by the author. So next, we will move on to the frameworks are used so that we can move to those directions. So, as mentioned earlier, there are a lot of EA frameworks available, but there were only two criteria used in selecting the five that we will discuss. Uh, so first, it should be a widely used and highly evaluated EA framework, and second, it should support mobile IT and cloud computing and web service elements. So according to a survey in the journal Enterprise Architecture, from the perspective of the widely used criteria, uh, it's the TOGAF and DODAF, so it's A and C that are most widely used uh, frameworks, and it's TOGAF, PF, and DODAF, so A, B, and C, uh, which were selected based on being highly evaluated. So for the second criterion, the selection is an integration with the elemental framework of mobile IT cloud computing and services, uh, which is part of uh, the SOA. So it is also argued that PF, TOGA, and all are uh, both very useful for business. So we will discuss what these five are in the next slide. So here's a quick table from the chapter, but since it's too complicated, here's a summary of the five. So TOGAF is short for the Open Group Architecture Framework. So TOGAF and DODAF, the third one, are the most widely used. And since they're both developed by the Open Group, their core is using the architecture development method. So it's quite a misnomer for DODAF because its name is Department of Defense Architecture Framework. So it could easily be mistaken as a government design framework, but it's not. But the but there are also two government design frameworks in the chapter. So second on the list is the FIAP, or the Federal Enterprise Architecture. So it has two cores: the collaborative planning methodology and the consolidated reference model. So we'll discuss that in the next slides. Uh, Also, MODAF, or the Ministry of Defense Framework, which was developed by the UK Ministry of Defense, is also a government framework. So it aims to support defense planning and change management activities. It's also a meta model that defines the relationship between all data in all the views. And then lastly is the adaptive enterprise architecture, which is also known as the Guild framework. So it has its core on the adaptive enterprise architecture framework. And right, so adaptive enterprise services are uh, developing and managing adaptive or agile enterprise architecture in the modern context. Also deals with the theory of the system of systems, so which is SOS. So here is a visualization of the ADM. So ADM in the previous slide, it's used by the TOGAF and DODAF, so the architecture development method. So it starts from first having a architecture vision, and then using that to manage requirements, while also having uh, quick business architecture plan and the preliminary results, and you follow the arrows. This is how it works. So the next is FIAF. So, as mentioned earlier, it has two cores: the collaborative planning methodology and the consolidated reference model. I think the consolidated reference model was more used, uh, especially because it has a lot of different subtypes. So it has six subtypes, which are the performance reference model, business reference model, data reference model, and so forth. Uh, Also, lastly, this is the GIL framework. So I think it's a lot to absorb, but thankfully, the author already did experiments, and we will discuss that with the next section of the report, which are the problems and solutions in digital transformation. So, as results of investigations regarding problems in digital transformation and related architecture in global corporations, and previous research in Australia and worldwide, the author considered the following seven kinds of factors, categories in their problem structures. So, first factor is the factor of uh, architecture strategy and governance. Next is the factor of business architecture. Third is the factor of uh, spanning business architecture and application architecture, as well as their dependencies. Fourth is factor of spanning application architecture and technology architecture, including their dependencies. Fifth is the factor on data architecture. Number six is the factor of spanning data architecture and technology architecture, including again the dependencies. And number seven is a factor of technology architecture. So what the research paper suggests is by keeping these factors in mind while looking for problems, we can create proper solutions for the problems that we can see. So here is a table. So as we can see, so if we can see the BA factor, so that's number two. So the left upper left part here is number two in the problems list. So BA factor. So to be more customer face organization, meeting evolving needs of customer clients in delayed business processes. So by using this business architecture platform, we can uh, properly define uh, what the problems are and what directions should be used. So moving on to the next slide is solutions to cope with problems in digital transformation and enterprise architecture. So from one to six, they are all different variations of the adaptive integrated digital architecture framework, or also known as IDA. So these six variations are whole, speed, responsiveness, flexibility, leanness, and learning. So number one is actually combination of all two to six together. Uh, Seventh solution would be the assessment meta model on architecture board, and eight would be the social collaboration model for architecture review in architecture board. Uh, Nine is the GDTC model for knowledge management on digital platforms. So GDTC is Global Digital Transformation Communication. And also, lastly, STRMM model for digital transformation. So STRMM is mostly a risk mitigation model with the architecture board toward the digital transformation while still being involved It's worth noting that all of them are involved in the IDAF, as you can see in this chart. So the big uh, blue box on the left is what the IDAF is, and it shows where each solution overlaps into the IDAF framework. So this chapter deals much with how IDAF has been successful in developing uh, these architecture frameworks for businesses. So, for the purpose of proceeding with IT strategy, promoting cloud, mobile IT, digital IT, and big data, the author introduces the strategic architecture approach and framework in the era of digital IT in this research. So, this approach and framework suit the requirements of digital IT related application systems that needs the agility elements while coping with each life cycle defined in the system development life cycle. So when we say the agility elements, these are actually the words in parentheses next to IDAF here. So the speed, responsiveness, flexibility, leanness, and learning. Okay, so here's another table that shows the seven identified problem factors next to the solutions. So we can see if we are able to identify the problems based on those factors, we can manage to uh, arrive at a solution that is also identified by the author here. So one of the 10 solutions here. And uh, here is a flowchart of how IDAF works. So if you can do that. So I think, the chapter focuses on how IDAF actually helps in mitigating the problems faced by businesses. So we go to conclusion. So the author briefed that the IDAF, or the Adaptive Integrated Digital Architecture Framework, is developed to meet the requirements of the era of cloud, mobile IT, digital IT, which involves the five agility elements of speed, responsiveness, flexibility, leanness, and learning. Furthermore, the author explained that IDAF can solve problems occurring in the era of cloud, mobile IT, and digital IT. So it could be compared side by side in the next chapter, which is 15, with this Scrum model. But for this chapter, it's only the IDA that is identified to be one of the most effective uh, ways in identifying problems and solutions within an enterprise architecture. So that's all for now. Thank you for your time.